Welcome to the Algebra 2, Chapter 6, Part B review. This is for sections 4 through 7. Please make sure you follow along and ask me any questions when you get to class. So the first problem here wants us to simplify this division problem between two different radicals. Now, the first thing I see is that I do have two different index values here. So I can't just look at these as they are now. What I need to do is I need to change them from radical form into exponential form. So when I change the top into exponential form, I will have x to the 4/6. The denominator will be x to the 4/9. That didn't come out very clear. So x to the 4/6 over x to the 4/9. Now remember, those are exponents. I'm not like multiplying them. It's not a number next to it. These are exponents. X to the 4/6 and x to the 4/9. Now when I have division happening between between the same base, I can just subtract my exponents. So the way I can write this here is x to the 4/6 minus x, I'm sorry, I don't want that other x there. I just want x to the 4/6 minus 4/9. Now, this is something that we can put into our calculator. We can ask our calculator what is 4/6 minus 4/9, or you have to go through and you need to get a common denominator so that you can subtract those two fractions. When I put 4/6 minus 4/9 into my calculator, the answer that I get is 2/9. So my answer, when this is all simplified, is x to the 2/9. All right, so now we're looking at a little bit more. Here, though, instead of division, like we had in number 1, number 2 is taking two radicals and multiplying them together. Again, though, the index on this first is 2. The index on the second is 8. So at this point in time, I cannot just multiply through. I'm going to have to change them into exponential form. So we're going to go ahead and do that again here. I have, my first one is 2. Remember, there's a little 1 there that we don't usually write, and there's a 2 there that we don't usually write. So that's 2 to the 1/2 power times 2, there's my invisible 1, to the 1/8 power. Now, when I'm multiplying my like bases, I'm going to add exponents. So this is the same as saying 2 to the 1/2 plus 1/8. Again, when we do 1/2 plus 1/8, we can either ask our calculator to help us out, or we need to get a common denominator and then add those fractions. When I put this in my calculator, it tells me that 1/2 plus 1/8 is equal to 5/8. So my answer is going to be my base of 2 to the 5/8 power, B. Number 3, I see two things. In my exponent, I see a negative and I see a decimal. The negative we take care of by flipping our base over the fraction bar. This decimal we need to turn into a fraction. So I'm going to put 1.5 into my calculator, and I'm going to ask it to convert it into a fraction. Remember, you can use that double arrow button at the bottom right above enter. So this is really 25 to the negative 3/2 power. That negative is going to flip it into the bottom. So instead of 25 over 1, we have 1 over 25. And now my exponent is positive. Last thing I'm going to do is I'm going to actually evaluate what 25 to the 3/2 is. I can do this by converting back into radical form. My 25 and my 3 go inside. Remember, if we use the sun method, if there's a sun here, the 25 and the 3 are really getting hit by the sun, so they need to go in the air conditioning. But the 2 is perfectly content where he's at. We can either write a 2 here, or we can just leave it, because a regular radical is understood to be a square root. We don't have to write the index of 2 there. Okay, so now if we have 3 25s and everything needs to be grouped up into 2s. So I have 3 25s, everything needs to be grouped up into 2s. How many groups of 25 can I take out? I can take out one group of 25s. So I get 1 over, I can take out one group of 25s, and I still have 1 left over. Well, we know what the square root of 25 is. It's equal to 5. So 1 over 25 times 5. This value here, 25 times 5, is 125. So my final answer is A, 1 over 125. This word problem here is very similar to a problem that we did in class. So I'm going to go through, there's a few things I need to identify first. First, let me read through the problem and underline anything that's important. You have a coupon good for $6 off the price of any large pizza. You also get a 20% discount on any pizza if you show your student ID. How much more would you pay for a large pizza if the cashier applies the coupon first? Okay, so I have two things. I have an f of x function, which we're going to say is going to be the coupon. We also have a g of x function, which we're going to say is the discount. All right, and then we have our variable, x, which is the cost of a large pizza. Okay, so let's go ahead through and take a look at this. I've got f of x as my coupon. I need to figure out how I represent that as an equation. If I have a coupon that's taking $6 off of my price, well, then that's going to equal the cost of my pizza minus $6. My discount is going to be a little bit different. That's g of x. That's going to be the cost of my pizza, but then I'm going to subtract only 20% of that cost, which we write as 0.20. Now, this equation that we just constructed, we can simplify. So we're going to simplify that. X minus 0.20x equals 0.80x, which makes sense because if it's 20% off, then I'm paying 80% of the actual cost. Okay, so we've got our f of x, we've got our g of x. Now the way we're going to determine which way the coupon or the discount first is better is by using composite functions. So I'm going to compose, do f of g of x and g of f of x. We're going to look at both of those different cases and see what happens. Okay, so let's use some different colors here so we can keep track of what's happening. I'm going to say that f of x is yellow, and I'm going to say that g of x is purple. Okay, f of g of x. I'm going to start with f, and I'm going to write that exact thing except where I see x, I'm going to insert parentheses. So I have parentheses minus 6. In that set of parentheses, I need to plug in g of x, which was 0.80x. Now we can't simplify that anymore, so I'm just going to write out 0.80x minus 6. That's my answer for f of g of x. Now for g of f of x, I start with g, and I'm going to write that exact thing, but instead of the x, I'm going to put a big set of open parentheses. And in those parentheses, I have to plug in f. Now this I can simplify because I can distribute, which will get me 0.80x minus 4.8. If you look at these two answers that we just got, this first one, I'm going to get 80% of my cost, so I'm getting the 20% off, and then I'm also taking $6 off of my price. The second way, we get the pizza for 80% of its actual cost, which means my 20% off, but I'm only getting an extra $4.8 off of my total price. So clearly this first option is better. Now the question says, how much more would you pay for the larger pizza? Well, what's the difference between 6 and 4.8? Your answer is $1.20. So C would be your answer here. So for this word problem, we need to figure out what our two functions are first. So I'm going to go through and I'm going to identify my f of x value and my g of x value. Let's say f of x is the 25% discount. And we'll say that g of x is the employee discount that's a 10% discount. So when we write these things as actual functions, a 25% discount is really the cost of the item minus 0.25 times the cost of that item, which is 0.75 times the cost of the item. Now you'll notice that I just used x and every time I said cost of the items, but I haven't defined that yet, so let's define that real quick. X equals cost of items. Okay, now the 10% is really going to be x minus 0.10 x, which equals 0.90x, or just 0.9x. So these are my two functions here that we just found, f of x and g of x. Now what I need to do is I have to compose them to see which one's going to save me the most money. So let's do f of g of x first, which means I'm plugging into my f of x, my g of x. And that will give me 0.675x. Now we have to check g of f of x, which is where I'm plugging into g of x. And I will plug in my f of x. Well, that also gets me 0.675x. So what this tells me, because these are the exact same thing, is that it doesn't matter which of those discounts I use first, because it's just going to take off a certain percentage and then take off another certain percentage. So C is my answer. It doesn't matter which discount is applied first. Now for number 6, what we're doing is we're multiplying two values together, and you notice that the base value is the same. I have 20s there. So when my base is the same number and I'm multiplying, all I have to do is add my exponents. So this is really the same as 20 to the 1/2 plus 1/2, which equals 20 to the first power, which is really just the number 20. Now 7's a little bit different because this 9 is not the same as this 3. So what I'm going to do is I'm going to put both of these things into radical form. And then I'm going to try to do Joe's method. I do know that the number 3 is not going to simplify anymore, but let's take a look at 9 and see what happens to 9. 9 divided by 3 is 3, divided by 3 is 1. I need groups of 3, which I don't have, but let's try something else. We're going to multiply these things. Because I can't simplify yet, I'm going to go through, and I see that I have the same index, which means I can multiply these two radicals. What happens is I keep that same index, but what is 9 times 3? That gets me 27. So now I have one radical. I'm going to try to do Joe's method with that. 27 divided by 3 is 9, divided by 3 is 3, divided by 3 is 1. And now you can see you do have a group of 3's that will come out. You have nothing left under the radical, so that goes away, and your answer is just the number 3. Okay, so this problem is asking us to write this exponential expression in radical form. Now, what's really important is that this exponent right here, this 3/8, is only on the x. The 3 has nothing to do with it. So I'm going to write my 3. Then I'm going to take just my x and put it into radical form. So remember, if you think about the sun method, the x and the 3 are really hot, but the 8 was in the shade, so he's perfectly content staying outside of the house. That is your answer. The 3 stays outside. The 3 has nothing to do with that exponent, so just the x is going to go inside with that third power, and the 8 stays outside as my index. Okay, here I'm doing a little bit of distribution with my exponent. So let's take this negative 2/3. We're going to distribute it into everything within our set of parentheses. So I'm going to have 8 to the negative 2/3. And then when I multiply negative 3 times negative 2/3, you can ask your calculator to help you with this too. Because I'm distributing to the A, I'm going to get 6/3, which is just 2. So A to the second power. So I've distributed in that negative 2/3 exponent, which is on the outside. Remember, you're multiplying when you do it, just like what we did over here. And now the only other thing I have to look at is that this exponent is negative, and we're not allowed to have negative exponents. So what I need to do is I need to rewrite this with my a squared staying on top of the fraction, but my 8 to the 2/3 has to move to the bottom so that now I don't have a negative exponent. And now I'm going to just see if I can simplify that 8 to the 2/3. So I'm going to rewrite it in radical form. Get 8 squared under cubed root. And I really know that 8 squared is 64. So I have 64 under a cubed root. And now I'm going to do Joe's method with the number 64. 64 divided by 2 is 32. Divided by 2 is 16. Divided by 2 is 8. 2 is 4. 2 is 2. And 2 is 1. And I'm looking for groups of 3. So let's see. I've got one group of 3. I've got 2 perfect groups of 3. So I'm going to rewrite this, 2 times 2, because I'm taking both of these out, gets me 4. There's nothing left underneath that radical, so this is my answer, a squared over 4. For this next problem, we need to go through and we need to solve for x. I see that I have a radical. Remember, whenever we're looking at solving problems with radicals in them, the first step is to isolate that radical. So I'm going to go ahead and I'm going to add 7 to both sides, so I can get rid of that 7. And I end up with the radical x plus 10 equals 2. So now what I'm going to do in order to get rid of this radical is I'm going to square both sides. The square and the square root cancel out, and I'm left with x plus 10 equals 4. Now this is just a simple equation that we can go ahead and solve by subtracting 10 from each side, which gives us x equals negative 6. This next problem is really similar, except for the fact that rather than having a radical, we have this fractional exponent. So we're going to follow the same sort of procedure. We need to isolate that thing before we can get going. And looking at this problem, it is already isolated. I have just my set of parentheses with that exponent. There's nothing else on my left side. So I'm going to go ahead and start out immediately by taking each side and raising it to that reciprocal power, which is 5/3. So each side has been raised to the 5/3 power. Now on the left, that cancels out completely, and I'm just left with x plus 6. On the right, I'm going to leave it as 8 to the 5/3 power, and then I'm going to go through and look at that in terms of Joe's method. So off to the side, let's do that. If I've got 8 to the 5/3, it's going to be 8 to the 5th power with an index of 3, which means I have 8 5s. And I'm looking for groups of 3, which means I can take one of them out. So I'm going to leave one 8 in front, and then I still have 8 squared underneath, which is really the number 64. So I've got the cubed root of 64. Now you're probably starting to memorize some of these. I know that that's going to be 4. You could do Joe's method and go through. You're going to keep dividing by 2, etc., etc., etc. But the cubed root of 64 is the number 4. So, sorry, that equal sign should not be there. So I have 8 already pulled out, but now I'm taking out another factor of 4, so I need to multiply those two numbers together. I get 32. So this thing right here, we just simplified all the way down to the number 32. So let's plug that in. Now I can go ahead and solve by subtracting 6 from both sides. I get x equals 26. All right, next problem. I've got my f of x and I've got my g of x. All I have to do is add them together. So I have f of x plus g of x. Now when I'm adding, all I'm doing is looking for like terms. I see that this negative 5x and positive 6x will go together, and that will reduce to just x, 1x. I also see that my negative 4 and my negative 7 will come together to give me negative 11. So that is my answer for f of x plus g of x. Now when I'm subtracting two functions, I do have to include one more step. I'm going to take my f of x and my g of x, and I'm going to write them in here. However, I need to remember to distribute this negative sign. So I have x plus 1 minus 2x minus 2. Now I can go ahead and look for my like terms. So x minus 2x is going to give me negative x, and then I can add my 1, my negative 2 to give me negative 1. So f of x minus g of x is negative x minus 1. Now when looking at this problem, I see that I have multiplication happening here. I see this little dot here, which is telling me I need to multiply. So I'm going to write those two things out next to each other in my parentheses. And multiplying is simply doing distribution. So I'm going to take my 3x multiplied to my 7x. That gives me 21x squared. 3x to 6 gives me 18x. 2 to 7x gives me 14x. And 2 to my 6 gives me 12. Now I see that I have my 18x and my 14x that I can combine. And I end up with 21x squared plus 32x plus 12. My order is written high to low, so I am done. Now division is going to be a little bit more tricky here. I'm going to write my f of x and my g of x. F of x is 5x minus 5 divided by g of x is x minus 1. Now if I look at this top function, I see that I can factor it by doing greatest common factor. I have a common 5, so I'm going to take that out to the front and get 5 times x minus 1. So I've factored my top function, which in result has given me these two things canceling out. And my answer that I'm left with is simply 5. But I do have to be careful because when I did that, I canceled out something that I need for my domain. Even though my answer is just 5, I did at some point have something in the denominator, this x minus 1. So I need to make sure in my domain that I state x minus 1 cannot equal 0. I add my 1 to both sides, and I know that x cannot equal 1. That is my domain, not all reals, even though my answer ended up being 5. I need to take a look at this and I remember that x cannot equal 1. All right, now we're going to look at some composing. So I have f of g of negative 5. Now remember, we're going to work backwards. We're going to take negative 5, we're going to plug it into g. First I'm going to do that, see what I get. So negative 4 times negative 5 plus 3. Negative 4 times negative 5 is 20, plus 3, I get 23. Now that I've got one of my answers, I'm going to take that 23 and plug it back into f. So negative 2 times 23 minus 7. 23 times a negative 2 gets me a negative 46, and I'm subtracting 7 from that, which gives me negative 53. So after I plugged negative 5 into g, I ended up with the value 23, which I then had to plug into f, giving me my final answer of negative 53. We've got another problem here that I'm being asked to compose. It's slightly different notation because it's got this composition circle right here, but it means the same thing. So I'm going to follow the same process. I'm going to take negative 5. This time I'm going to plug it into f first because f is the closest thing to it, which gives me negative 5 plus 2, which is the value negative 3. Now that I've got negative 3, I'm going to take that and plug it in to g. So I've got negative 3 squared. That gives me a value of 9, and that's my answer. All right, here we're graphing the relation and its inverse using open circles to graph the points of the inverse. So if I look at my relation that I've been given, I've got 4 points. 0, 3, 4, 2, 9, 7. I'm going to kind of guesstimate that one to be right there. I'll make it a different color so you can see it better. And 10, negative 1. I'm going to have to estimate that one too. I'm going to say that's going to be about right there. So those are all closed circles. That's what I'm using to graph my relation. And then I'm going to go ahead and find the points for my inverse. The way I do that is by creating another table of values, except here I'm just switching my x and my y values that I was given. So instead of the point 0, 3, I have the point 3, 0. Instead of 4, 2, I have 2, 4. I have 7, 9. And I have negative 1, 10. So I'm going to plot those points on this graph as open circles. So I've got 3, 0. I've got 2, 4. 7, 9, which is going to have to be estimated a little bit. Maybe about right there. And negative 1, 10, which is also going to be estimated maybe about right there. So I've got all of my points plotted, and look at, remember we talked about how there was always going to be this line of reflection right here? You can see that that is in fact true for this case as well. All right, so this question asks us whether the relation that they've given us is a function, and then is the inverse a function? Okay, so there's a really quick way to determine this, and basically that quick way is that you cannot have the same x's going to two different points. No x's going to two different values. So basically I'm looking for repeating x's, and if my x's do repeat, there better be the same value there, which would be silly because it would be writing the same point twice. But let's take a look. Looking at my x's here, I have 0, 2, 4, 6. Do any of my x's repeat? No. So my relation is a function. T is a function. Now though, we have to also look at our inverse. So let's go ahead and let's make our xy chart where we're going to put our inverse. I'm switching all of my points, so it's going to be negative 8, 0, negative 7, 2, negative 4, 4, and negative 4, 6. All I did is I switched each of my values for my t inverse. Now looking, do I have any x's that repeat? I have negative 8, negative 7. Oh boy, I have two negative 4 values, and they're going to two different y values. So t inverse is not a function. So for this problem, when we're finding the inverse, I have to do two things. First, I'm switching my x and my y values. So I have x equals 3y plus 9. And then I'm solving for 9. So I'm going to move my, solving for y. So I'm moving my 9. I get 3y and x minus 9. And now I'm simply going to divide by 3, canceling that out, which gets me y by itself equal to x minus 9 over 3. And that would be my inverse relation.